Okay, let's talk about the powers of adjacency matrix. All right. So we are not expecting you to actually calculate the power of adjacency matrix, but you do need to know how to use the calculator and know how to interpret it. So basically, you've got a matrix. It's a square matrix.
This is going to be on the text. I think you'll probably put like a dot operation.
All right. It's a square matrix. Only a square matrix you can have a power to it. So the power could be to the power of 2, could be to the power of 3, could be to the power of 4, whatever. So we're going to learn how to use the class pad to actually work out the powers of the adjacency matrix and also how to interpret it. Alright? Interpreting is important. How to interpret it is more important than knowing how to use a class pad, alright? So you do need to know how to use it. Now, from yesterday, I did give you the definition of an adjacency matrix, right? So if you could remember, an adjacency matrix or graph containing n vertices is actually a square matrix of order n times n. Entry in row I and column j is the number of edges that are joining vertices I and j. So that was yesterday. All right, you know, always from somewhere to somewhere. All right, and it is always a square matrix. Now, the leading diagonal will tell you whether there's a loop. All right, the leading diagonal will tell you whether there's a loop. If there is a number there, means there's a loop. So if there's 1, A will have 1 loop. If there's 2, B actually has 2 loops. All right, so think about that. If it is symmetrical, about the leading diagonal, it is undirected. But if the number is different, it is directed graph. All right? So now, I've asked you to, yesterday we did construct an adjacency matrix for this. Remember? I hope you do. Let me change that. Now, what I'm going to do is ask you to think about, there is actually no way we could travel from A to C directly, correct? Yeah. There is no connection. However, if I want to travel to C, I can actually use ABC, yeah, or ADC, this one, or ADC. There are 3 ways of traveling to, 3 ways of traveling to C, correct? Yeah? So, is it possible to travel from E to A?
Yeah.
Yes, we can. We can use this way. E, B, A. All right? We could use E, C, B, A. Yeah? Agree? E, C, B, A. Yeah? We can do that. So, we could travel from E to A. But if we want to use only 2 edges, if we want to use 2 edges only, from E to A, we can only go from E to B to A, correct? Yeah. From E to A, if I go through C, that's 1, 2, and 3, using 3 edges. Yeah? If I go the other way, it's the same thing. 1, 2, and 3. All right? So, what I want you all to think about is this time, the power of the adjacency matrix actually tells us how many edges we need to go from one place to the other. Or think about it as the length of the walk. The length of the walk could be 2, could be 3, could be 4, not 1. The length of the walk of 1 is B to C, or E to C. That's all. All right. So here, when we have the adjacency matrix, it's just basically using one edge from one to the other, and the length of walk is 1. All right. Now, if we let n represent this matrix, we can use our class pad to determine the square of the matrix. Can you get your class pad out, please? All right. So let me write it down. I'll show you how to put in 1, 1, 0, 1, 0. All right. 1, 0, 1, 0, 1, 0, 1, 0, 2, 1, 1, 0, 2, 0, 0, 0, 1, 1, 0, 0. All right, have I got it right? 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1. Hey, now, if you got your class back up, all right? Go to name. Again, I'm going to advise you, if you are starting a new question, just make sure that you clear everything. Edit, clear all variables, and clear all. All right? Make sure that you clear everything. That's important. If you haven't got a class back, come and get one from me, please. All right? Here, go to keyboard. Under Math 2. This one here is your matrix. So if you tap on that, it will come up with a 2 by 2 matrix. If you want extra column and row, tap on it again, tap on it again, tap on it again. Now you've got 5 by 5 matrix. All right? And to input, just go into each box 0, 1, 0, 1. That's no quick way of doing it. You have to just be able to type it in. Make sure that you type it in correctly. You just have to type it in. There's no quick way of doing it. Sorry. It's a little bit easier using your class pad instead of using the simulator. All right. 0, 2. I think I'm getting there. Now, once you type it in, yeah.
It's a 1 after the 2 in that row, yeah.
Is there which one?
Yeah, middle row.
Well, yeah, I haven't done it yet. I haven't quite finished yet. Yes. So that should look the same as this. Yeah, all right, it is. All right, now, once you've done it, what you need to do is have on there, outside the matrix, and you use your, actually just use this sign here, to the power of 2. That's all. It will give you n squared. All right? So if to the power of 2 is n squared, and you got a whole lot of number coming out, what does it mean? All right, let's have a look at this.
Two steps.
2 steps. It is a 2 steps. So this is like A, B, C, D, E. From A, B, C, D, E. So it is telling me if I go traveling from A and back to A, all right? I have got, this is m squared, 2 ways of length 2, walk of length 2, or using 2 edges from A to A. So it's something like this. You go from A back to A once, and second time A back to A once. All right. So there are 2 walk with the length of 2 m squared. All right. So here, in this case, I want to go from D to D. 5 ways of going from D to D with using 2 edges, or actually with a walk of length of 2. All right. So So C to C, that's 6, and C to A. From C to A, 3, which means you have got 3 ways of going from C to A, and with 2 edges. All right, let me go back to my slide.
I don't know how we're drawing matrix.
So this is what I get.
Drawing 6 fucking 80.
That square, or use your class back. This is how I showed you. I've got it recorded so that you know how to use it. Now, so this matrix tells us how many ways there are to travel between each pair of nodes or each pair of vertices using exactly 2 edges. All right, the 2 in position M11. Oops. So M11, row 1, column 1. All right, indicates that it is possible to travel from node A back to itself using 2 edges. Walk length of 2 in 2 different ways. What you have to realize that sometimes you are not asked to calculate this matrix at all. All right, you are not asked to calculate matrix, but you'll be told that position M3 1. So M3 row 3 and 1 is this. How do you interpret that question? How do you interpret that? All right. So there are questions that will ask you, instead of you calculating the power, they will tell you it's n squared 3 1. What is that? Or n cubed 3 1. All right. So here, the 2 in the position M11, M11 indicates that it is possible to travel from node A back to itself using 2 edges, walk length of 2. And the position O in M12, M row 1, and column 2, row 1 and column 2, row 1 and column 2 suggests that there's no path of length 2 that starts at A and ends at B. All right. So those are the things that you have to consider. I can go through a lot of it, but you've got to be able to understand that. That's just way too many combinations for me to go through. Now here, what about using 3 edges from A to E? So I want to go from A to E. I go here, 1 edge, B, C, and E. 3 edges. All right. I can also go A to D, D to C, C to E. Right? A to D, D to C, C to E. There are 3 edges. Now, or walk length of 3. How do I do that? Same thing. I will use this matrix, but this time I take the power of 3. Can you all try it, please? Grab your calculator, just copy and paste. So if you got a calculator there, you can just do a copy and paste. All right? Do not use this. Do not use the m square. Go back to m. Just highlight that, edit, copy, and then go back to the bottom, edit, paste. Paste that, and then you go power of 3. And click execute, and you get your answer. All right? So this time, you're using 3 edges. N cubed means 3 edges. N to the power of 4, 4 edges. All right? So using the class back, you can determine the cube of matrix N, which is a 3-stage matrix using 3 edges. Walk length of 3, or with 2 stopovers. So you got to understand, you could use the word 2 stopovers. The question may ask you how many stopovers. It may ask you how many edges or length. All right? So make sure that you understand the difference or the length of walk. All right? The length of walk is basically the total length of walk is the number of edges, but the stopover is 1 less. All right? Because you go to A, B, and come back. So that's one stopover, but that's 2 stages. 2 edges, 2 stages. Cube, you've got that. And you can use your class back. Using the class back is pretty straightforward. But I would say that I've seen a lot of the questions that they don't actually give you, ask you to use the class tag. Just basically give you the power and get you to describe, interpret it. Okay? Always interpret in terms of the context of the question. Can you try that, please? Can you construct adjacency matrix for the graph? I did that yesterday. It's exactly the same. I'm using the same example. All right? All right. Construct the adjacency matrix P. So just remember, it could be matrix P, matrix M, whatever. This one, it has a loop. So the leading diagonal, there will be a number there, not just a 0. One more lesson tomorrow, then they'll cover the whole topic of graph network. And Friday I'll do a summary here. Put in A, B, C, D. It should be, I should have put in from and to. But this is P. Now, do you agree with me?
Yeah.
The adjacency matrix, same? Yeah? Alright. The question is, can you travel from A to B using 2 edges, length of walk 2?
Yes.
Yes? How?
A,
Sorry?
D,
A, D, B. Very good. Okay? So that's pretty straightforward. You can use that. Now, what about going from A to B using using 3 edges?
Yeah.
Can you?
Yeah. A and D.
Think about the loop. The loop is considered as one walk. So you could go 3 edges, A, D, and B. Yeah? Yeah? What about 4?
I think you can anywhere.
You can. You can. 1, 2, 3, 4. Think about the loop. Loop you can always repeat. Loop you can always repeat. That's a question that's always trick people. Loop you can always repeat. So if you want to go 1,000 times to B, 1,000 edges to B, just remember 1 and 2, that's 2 edges. 1,000 minus 2, 998 times. Loop. Alright? The loop you can keep going. So that's a tricky bit. Alright? That's a tricky bit. Just remember the loop, that's never ending. 1, 2, 3, 4, 5, 6. Okay? So, if I want to do traveling from A to B using 3 edges, of course I can't do that. I can't do that, but here, A, D, and B. Alright? So, to the power of 3, that's only 1. So, A to D, 1. See? Got it? Yeah? So, remember the loop. You can do it multiple times. I've seen questions like that coming with loop, and about half people got it wrong because people didn't understand you can go through the loop. The question was there's something like this, and you were asked if you can get from A to B without calculating without using the adjacency matrix, whether you could go from A to B with a walk length of 7. I give examples. Alright, so remember the loop. Alright, now this is just a summary. For any adjacency matrix M, N gives the number of walk lengths of 1 between the vertices, no stopover. N square is number of walk length of 2, or using 2 edges, 1 stopover. N3 gives the number of walk lengths of 3 between 2 vertices, or 2 stopover. Alright? So what you need to realize that n to the power of n, anything, will give the number of walkways of length n between each pair of vertices, or number of edges used. And then n minus 1 stopover. I've seen question with stopover or question with number of edges, question with length of wall. All right? Yep. You can reuse the edges. You can reuse the edges. So for this, the power of adjacency matrix, it doesn't matter whether it's direct or non-directed. All right? Okay, I'm going to stop here. There should be plenty of exercises in class for you to do. All right? Now, with the test,